Hello everyone, in this video I want to talk about how to divide polynomials using the method of long division. So there is another method called synthetic division, and we'll get into that in a separate video. So here we're going to focus on long division. We're going to talk about some characteristics of long division at the beginning of the video, and then we're going to do two examples of a long division with polynomials. So first of all, when we divide a polynomial by a non-zero polynomial divisor, we're going to get a quotient polynomial and a remainder polynomial. Now, sometimes we might get a remainder of 0, and so that's what the second bullet point in yellow tells us. When the remainder is 0, the divisor divides evenly into the dividend. So we're going to see one example where we do have a remainder and one example where we do not have a remainder. In the middle there in white, it says the degree of the remainder must be less than the degree of the divisor. So when we look at example 1 here, we are dividing 4x to the fourth plus 5x minus 4 by x squared minus 3x minus 2. So we want to make sure our remainder has a degree less than 2 because our divisor over here is a quadratic divisor, right? It has an exponent of 2. So we've gone ahead and written out this in long division, and so we put x squared minus 3x minus 2 outside of our little house, I've heard it called before, as our divisor. And our dividend is going to be 4x to the fourth plus 5x minus 4. And notice how I've written that under my long division symbol. We've got 4x to the fourth, but we don't have a cubic term and we don't have a quadratic term. So we're going to add in that as 0x to the third and 0x squared. So we need to do that for our long division. And then we have our 5x and our negative 4, okay? So now what we're going to do is we are going to focus on this first term of our trinomial divisor. And we're going to ask ourselves, how many times will x squared go into 4x to the fourth? So what we mean by that is if we took 4x to the fourth and divided it by x squared, what would the result be? Well, we know that we would divide, this would be 4 divided by 1, which is 4, and we can subtract our exponents, so this is going to be 4x squared. Okay, so now what we're going to do is we're going to put a 4x squared right there. And now we're going to take 4x squared and we're going to multiply it by all 3 of our terms of our divisor. So 4x squared times x squared is going to be 4x to the fourth. 4x squared times negative 3x would be negative 12x cubed. And 4x squared times negative 2 would be negative 8x squared. And now what we're going to do is we are going to subtract these results. Okay? So now, I know we have 5x and negative 4 still on the right side, but we don't need that yet. So we're not going to bring it down until we need it. So let's subtract here. So we know that term is going to go away. And now we have 0 minus negative 12x cubed. So be careful with your subtraction. That's probably where most students are going to make mistakes. So be careful there. So this is going to turn into a positive 12x cubed, 0x squared minus negative, so plus 8x squared. So now we're going to start this process over again. And now we're going to look at, okay, how many times will x squared go into 12x cubed? And so we could think about the same thing on the right side. So we could take 12x cubed divided by x squared. And we got that 1 there, so it's going to give us a 12x. So we can put plus 12x up here. And now we're going to multiply once again by all 3 of our terms. Okay? So I'm going to erase that. It's kind of jumbled a little bit for me. All right, so now we got 12x times x squared, which hopefully is 12x cubed. 12x times negative 3x, so minus 36x squared. 12x times negative 2, and we have minus 24x. Okay? All right, so now we are going to subtract. So now is when we need our 5. So now we can bring that down here, our 5x. Okay, so now let's subtract. Okay, so now once again our cubic terms should cancel out, and now we have 8 minus negative 36, or 8 plus 36, so that's 44x squared. And then we have 5 minus negative 24, or 5 plus 24x, so that's 29x. And now we're going to do the same thing again. So 44x squared, how many times will x squared go into that? So we could do 44x squared divided by x squared. And our x squareds are going to cancel out and we just get 44. So we can write plus 44 right here. So now once again, we're going to multiply 44 by all 3 of our terms on the outside of our division. So we're going to get 44x squared, and then we do 44 times negative 3x, and that's going to give us negative 132x. and 44 times negative 2, so negative 88. And now we need to bring down this negative 4, and now we are ready to subtract. So once again, that first term is going to cancel out, and now we have 29x minus negative 132x, or 29x plus 132x, and we get 161x. And then we have negative 4 minus negative 88, or negative 4 plus 88, and we get a positive 84. Now, at this point, notice that our remainder is now a degree lower than our divisor, right? We have just an x to the first here, or a linear term. So now we are done. We are ready to write our answer. This part right here is our remainder. So here's how we're going to write our answer. We're going to take what we have up here. So we're going to say 4x squared plus 12x plus 44, and we are going to add our remainder. So here's how we do our remainder. The numerator is the remainder that we got, 161x plus 84, and our denominator is our original divisor. So x squared minus 3x minus 2, and this would be the quotient to our problem. Okay, so this one was when we did have a remainder, and so now let's look at example 2 where we have a remainder of 0, or basically we don't have a remainder. So we're going to divide x to the 6th power minus 10x to the 4th plus 16x cubed minus 9x squared minus 4x plus 14 by x squared plus 2x minus 7. So once again, we're going to set it up, and we did not have an x to the 5th term, so that's why we have 0x to the 5th in our polynomial here. So once again, we're going to focus on this first term, and we're going to say how many times would x squared go into x to the 6th. So once again, we could just make a little note over here, and this would be x to the 4th. Okay, so we're basically applying an exponent rule here, where if we have the same base and we're dividing, we can subtract those exponents. So we're going to put x to the 4th right here, and now once again, we're going to multiply x to the 4th by all three of our terms on the outside. So this gives us x to the 6th plus 2x to the 5th, and then we have minus 7x to the 4th. Okay, so now we're going to subtract our terms here. We're going to cancel out there. 0x to the 5th minus 2x to the 5th, so that's a negative 2x to the 5th. Negative 10x to the 4th minus negative, or plus 7, so that's a negative 3x to the 4th. Okay, now we're going to say, okay, negative 2x to the 5th, how many times would x squared go into that? So we have our negative 2, and then we get x cubed. So negative 2x cubed we write up on the top. And now once again, we're going to multiply negative 2x cubed by all three of our terms on the outside. So that's going to give us a negative 2x to the 5th, and then negative 2x cubed times 2x would be negative 4x to the 4th. Negative 2x cubed times negative 7 would be positive 14x cubed. So now we need this 16x cubed, so we're going to bring it down, and now we are ready to subtract. So our x to the 5th terms will cancel out. Now we have negative 3x to the 4th minus negative, or plus 4x, so that's x to the 4th. And then 16x cubed minus 14x cubed, so 2x cubed. Okay. Now once again, we're going to see, okay, how many times will x squared go into x to the 4th? So we can come over here on the left again and do a little division to help us. Now we don't have to do this on the right side. This is just if we're having a hard time knowing how many times x squared will go into the term that we're at in our division problem. So this is x squared. So we're going to put plus x squared up here. And now we're going to multiply by all three of our terms on the outside. So we get x to the 4th, and then x squared times 2x would be plus 2x cubed, and x squared times negative 7 would be negative 7x squared. Okay, so now we're going to subtract. So to subtract, we need to make sure we bring down our negative 9x squared. And now we're going to cancel here, and now look what happens to our cubed term as well. That actually cancels out as well. So now we have negative 9x squared minus negative 7x squared, or plus 7, so this is a negative 2x squared. Okay, and now we can start again. Let's say, okay, we have negative 2x squared. How many times will x squared go into that? So we're going to divide, and we just get a negative 2 here. So we're going to put minus 2. And now we're going to take our negative 2, we're going to multiply by all three of our terms on the outside. So negative 2 times x squared would be negative 2x squared. Negative 2 times negative 2x would be negative 4x. And negative 2 times negative 7 would be plus 14. So now to subtract here, we're actually going to have to bring down both our linear term and our constant term. But now notice what happens. We go to subtract, our negative 2x squareds cancel, our negative 4x's cancel, and our 14's cancel, and we're left with a remainder of 0. So this will actually divide evenly, and so our answer would just be x to the 4th minus 2x cubed plus x squared minus 2, and there would be no remainder, okay? And so that is an example of how you can use long division to divide polynomials. One example with a remainder and one example without.